children, I'm back again. So here I'm going to solve few questions. I have taken a few questions. I have selected few questions already. I have selected almost 10 questions from physical chemistry. You can also ask your doubt in the comment section. But before that also I will suggest you to like and subscribe the video so that this video gets maximum likes and maximum reach. Okay, so I'm going to start solving few questions. So you can ask your doubts in the comment section. Here I am going to solve your few questions. Okay. This is the first question. In this question, you can see magnesium sulfate plus aqueous. Mg gives MgSO4 aqueous. So basically, it gives a solution of MgSO4. Delta H is given. Now the question is delta H of the reaction is known as. So clearly we can say this is a solution, aqueous solution of magnesium sulfate. So here delta H will be known as heat of solution. So B is the answer. B is our correct answer. Next, in which of the following reactions heat liberated is known as standard heat of formation? So in order to have standard heat of formation, you need to know that 1 mole of product should be formed. 1 mole, the product should be 1 mole. So the reactions where it is giving more than 1 mole should not be our answer. So obviously option A is not our answer. Option D is also not our answer, because in this two reaction we are getting 2 moles of the product. So this is not our answer. Next, between B and C, observe very carefully carbon diamond and carbon graphite. Between carbon diamond and graphite, carbon graphite is the most stable one. So this is the standard state of carbon. Graphite is the standard state of carbon. So basically C will be the correct answer, because here we are getting the carbon dioxide from the standard from the carbon which is in the standard state at room temperature. At normal standard condition, carbon exists in graphite. So obviously C will be the answer. In our next question, we have a question: an ideal gas is taken around the cycle ABCA as shown in the PV diagram. The net work done you have to find out. So here is the diagram. This is the diagram. In this diagram, we have to find the net work done. So observe very carefully. From A, the journey starts. A to B it goes, then from B to C, and then again C to A. It's a cyclic process basically. So you have to find the work done. So always remember, work done is calculated. Work done is nothing but the area under the graph, area. So clearly this area you have to find out. Now this is a triangle. For triangle, area of the triangle, we know it is half into base into height. So this is the base, AC. So we write half into AC into H. H is the height. This is the height. This is the H. So it will be AB. So clearly half into AC. So AC is this one, this difference. So obviously it will be 3V1 minus V1, that will be 2V1. So we can write 2V1. And what about AB? AB is the difference between these 2 points, that is 6P1 minus P1, which will give us 5P1. So we can write 5P1. So clearly 2 gets cancelled, we get 5P1 V1. So our answer will be 5P1 V1. Which one? C is the answer. So this is how we calculate. Next, so here we have a question: work done in isothermal W1, adiabatic W2, isobaric W3, isochoric W4 are reversible. Expansion lies in following sequence. So for that you have to know that there is a graph. We have a graph for the work done in various processes. So this graph, this is a graph, this is a graph, this is the pressure, this is the volume, this is the graph. Okay, this is the graph. Okay, now here pressure is constant. It is for the isobaric, it's for the isobaric, this is for the isochoric. Okay, this is for the isothermal, and this is for adiabatic. Okay, so maximum work under the graph you have to find out. So here maximum area for isobaric we will have the maximum area. This is the area under the isobaric. Okay, so isobaric represented by W3. So W3 will have the highest area. W3 either A or D. Now between A and D, both are having W3 high at the highest work done. Next, after isobaric, we should consider this isothermal. Isothermal means isothermal is represented by W1. That means after isobaric, we should have W1. So obviously option A is the correct answer. So next, for the reaction, this is the reaction. One reaction is given, Kp by Kc. So we have a relation between Kp and Kc. Kp is equal to Kc into RT to the power delta Ng. So from this reaction, you have to find the delta Ng. So delta Ng will be, delta Ng is number of product minus number of reactant. So product, how many moles? 1 mole. Reactant, how many moles? 1/2. That is 1 plus half. That is ultimately it will be minus half. So the power of RT should be minus half. So we can write Kp by Kc is equal to RT to the power minus half. So which option? C is the option. So this is how we can solve. Next, in which reaction the concentration of the product is higher than that of the reactants at equilibrium? So can you solve this question? If you have any doubt and if you have some own questions, you can share in the comment box. Anyways, so we are going to solve it. So for that I am giving you a hint. What is K? K is basically the concentration of the product divided by the concentration of the reactant. So from this hint you can easily identify the K should be, if the product is more, the K should be more than 1. So if the concentration of product is more, if this value is more, suppose for example 2 divided by 1, so obviously the value should be always more than 1. So in our option, product concentration is more, we can only find by knowing the value of K. The value of K should be more than 1. So more than 1, only one option is correct, that is B. So this way we can solve. Next, so the compound, next question, this is the next question. The compound A and B are mixed in equimolar proportion to form the product. AB is equal to C plus D. At equilibrium, 1/3 of A and B are consumed. The equilibrium constant for the reactant is. So for that you have to write the reaction. So this is the reaction: A plus B, reversible, C plus D. So initially let us suppose this is 1 mole, this is also 1 mole, this is 0, this is 0. Initially no product is formed, and at equilibrium we can say 1 minus, they said ki 1/3 of A and B are consumed. So 1/3, 1 minus 1/3, this is also 1 minus 1/3, product will be 1/3, this will be 1/3. Okay, now what is the value of K? So K is equal to concentration of product, that is C, concentration of C into concentration of D divided by concentration of the reactant. So you solve it, you will get 1 by 9, and this will be 2 by 3, 2 by 3, so you can write 1 by 9, and this will be 4 by 9, so ultimately you will get 1 by 4, that will be 0.25. So option D is the correct answer. Okay, so I have taken very few number of question. If you have any more question, you can directly give it to the comment box, type it to the comment box. I will take the question. What is the equilibrium constant for the reaction? For this reaction you have to find the equilibrium constant. So clearly we know that while writing the value for the equilibrium constant, we ignore the solids and liquids. We only consider the gaseous state and aqueous state. Okay, here we have gaseous, so obviously the K will be concentration of the product, that is this, but this is in solid state, so we'll write only 1 divided by concentration of the product, concentration of the reactant. So reactant we have P4 and O2, but P4 is solid, so we cannot consider this, so we have to consider the O2. So concentration of O2, O2 how many moles? 5 moles, so the power will be 5. So option, which one? Option B is the correct answer. So this way we can solve few questions. Now I doubt if we have any more question left. Yes, we don't have any more question. We have solved 8 questions. I told you that I have taken very less number of questions. If you have any doubt, you can ask. If you have any doubt, you can ask in the comment box. It doesn't matter whether it is from the NEET or JEE. If it is from the boards also, I will help. If you have any doubt, directly ask. Okay. Now if you are new, then I will again show you the beginning of the stream, from the beginning of the stream. Okay, so this was the first question that we have taken. Okay, so here there is a reaction of magnesium sulfate plus water. Magnesium sulfate and water, it gives a solution of magnesium sulfate, and delta H is given. The question is delta H of the reaction is known as, so it is a heat of solution. Why? Because it is making a solution with water. So similarly, next we did this question: in which of the following reaction heat liberated is known as standard heat of formation of CO2? So we know that CO2, for CO2, not only for CO2, anything for standard heat of formation, there should be always 1 mole of the product should be formed. So 1 mole, we have only B and C, we have 1 mole, but between B and C, in the standard state, carbon exists in graphite. The graphite is the standard state of carbon, so obviously C will be the correct answer. Next, we solve this question. In this question, we have taken we have calculated the work done. So here there is a graph given, PV graph. From the PV graph, you have to find the area under the graph. Why? Because you have to find the work done. Whenever they give this type of graph, you have to find the work done. So here this graph is given. From here we have to find the work done. For work done, you need to find the area under the curve. This curve is nothing but this is a cyclic process. It is a triangle. In this triangle, we have to find the area. So for the area, we have to use this formula, area of the triangle, which is half into base into hypotenuse. So it is half into AC. This is the AC and this is the AB. So after putting their value, AC means the difference between these 2 points, which is 3b1 minus b1, which will be 2b1, and height is this 6p1 minus p1, which is 5p1. So simply you just put the values, you will get 5p1 b1. So this way we can solve. Okay, so this is the next question. Here we are solving this work done isothermal W1, adiabatic W2, isobaric W3, isochoric W4, reversible expansion lies in the following sequence. So we know this, there is a graph of isobaric, isothermal, adiabatic, isochoric. So isobaric contains the maximum area under the curve. So obviously this isobaric will have the maximum work done. So obviously this isobaric represent W3 will have the maximum work. Next, after isobaric, we have to consider the isothermal, because isothermal has less amount of area under the graph, under the curve. So isothermal is represented by W1. So obviously after W3, W1 will come. Next, for the reaction, this reaction is given, you have to find the Kp, Kc, Kp by Kc. So Kp is equal to this. So obviously we can write Kp by Kc will be equal to RT to the power delta Ng. So for that delta Ng you have to find out the number of product minus number of reactant. Number of product is 1 mole, number of reactant is 1 plus half, that is 1/3. The third 3 by 2, so we can calculate. This will be give us minus half, so minus half we put here, you will get the answer, so which is option C. So similarly, this another question, in which reaction the concentration of the product is higher than that of the reactants at equilibrium. So we know that for K is nothing but the ratio of the product and reactants concentration. So if the product amount of product is more, the value will be more than 1. So obviously they mentioned the concentration of product is more, so obviously the value will be more than 1. Out of the 4 options, only options B satisfy the condition, so obviously B will be the answer. So this question, in the next question we have the compound A and B are mixed in equimolar proportion to form the product A plus B. This at equilibrium 1/3 of A and B are consumed. The equilibrium constant for the reaction is, so A, B, C, D, these are the 4 options. Now how to find out? For that you have to write the reaction. So after writing the reaction, mark the initial concentration. I have taken 1 mole of each, and product obviously will be 0. At equilibrium 1/3 of 1 will be removed, so 1/3 is removed, and that 1/3 will be formed as a product. So 1/3 is formed as a product. Now after that, K, find the value of K. K is nothing but the concentration of product at equilibrium divided by concentration of the reactant at equilibrium. So after putting this value we get 0.25, that is the answer, that is D. So this way we solve. Now this is the last question, what is the equilibrium constant for the reaction? So they have given a reaction, we need to know that the solid and liquid we do not mention their concentration, we represent their concentration as 1, because for solid and liquid the concentration are intensive property, and intensive property do not change, it is constant. So we will consider 1 for solid state. For solid state we consider 1, the concentration will be 1. Now obviously we can write the concentration of product, that is this, so obviously it will be 1 divided by concentration of product. Product for P4 it is 1 because it is solid. So for oxygen obviously it is in the gaseous state, so you have to mention it. And 5, this 5 mole represent the power 5. Now if you have any doubt or any question, you just ask me in the comment section, I will solve. Okay, so I'm closing the live. I'm going offline. So thank you for attention.